All right, friends, for this lesson, we are looking at page 31 in our awesome algebra book. Okay, so we are going to turn to page 31. Page 31, you will notice, is a hundreds chart. So we're going to be using this chart to help us with our lesson for today. Okay, now you'll notice it is labeled from 1 to 10, okay, and then 11 counting down that way. Okay, you should also notice some patterns within this chart by itself. All of the 10s go down here. These are all numbers that end with 0. Okay, all of the ones that end with 1 all go down in this pattern, and the 2s in this pattern, the 3s, and so on and so forth. But we're going to use our hundreds chart to help us better understand multiples and how counting by a certain number gives us multiples of that number. All right, so flip to page 33. We're looking now at mini hundreds charts, okay? Now, considering the term multiple, what is it about the term that will help you think of multiplication? Hopefully, you're thinking counting by 2 gives us multiples of 2. So, with one of the highlighters or colored pencils that you have, we are going to take some time and we are going to only highlight the numbers that we count by 2s through repeated addition or multiplication. Okay, so multiples of 2. Now, I'm going to highlight 2, and then I'm going to skip count to 4, then to 6, 8, 10. Okay, I'm going to keep counting. After 10, when I add 2 more in my multiple, I get 12, then 14, then 16, then 18, and then 20. Take a moment to highlight all of those numbers that I see right there. Notice that I'm coloring it in neatly as well, because we're going to be using these as a reference to help us understand the patterns of these multiples. Okay, continuing, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40, 42, 44, 46, 48, 50. I'm just going to stop there for a second because I want you to turn and talk to your partner. Tell me if you notice anything right now in terms of a pattern. Okay, what do you see? Okay, hopefully you've said that all of the numbers here are ending by 2. All of the numbers here are ending by 4. All of the numbers here are ending by 6. These are all ending by 8, and these are all ending by 0. So we can continue to count by 2s, but since we already know what our pattern is, we can be under the assumption that the rest of the multiples of 2 are going to be in this particular fashion, where they are creating a pattern in our chart, and we can use some of our key scientific or mathematical vocabulary to help us explain what we see. Okay, so I'm going to stop for a moment to make sure everybody has their chart looking like that. Now we're going to take a moment to explain what it is that we notice. Are there any key mathematical vocabulary words that you could reference? Well, hopefully looking in your math journal, you could reference that we talked about vertical, okay, which goes up and down. We talked about horizontal, which goes from left to right. And we also talked about diagonal, which goes this way. And that's why it was so important for you to copy that in your math journal so you can use that as a reference. So hopefully you're able to say, using that mathematical vocabulary, that you notice the 2s, and we'll use a bullet here, are in vertical columns Notice I'm using the word columns. That's another key vocabulary word. Rows, columns, okay? Vertical, horizontal, diagonal. What else can you tell me? Well, all of the multiples of 2 through repeated addition, they end in 2, 4, 6, 8, or 0. So if I had a question to ask you, and we were taking this multiplication chart, and I asked you to find a number like goes to 1,000, which is one of our standards, okay, being able to add, subtract, multiply, and divide, so on and so forth, but adding and subtracting within 1,000, which column would you find 324? Hopefully, you would tell me that 324 would be in this column because it ends in a 4. Where would you find 876? Hopefully, tell me that it would be in this column because 876 ends with a 6. Okay? What if I asked you to find the number 527? Would 527 be highlighted? No, because 527 does not end in 2, 4, 6, 8, or 0. Okay? So, moving forward with that concept, we are now going to look at the 3s and the 4s. Okay? And again, I'm demonstrating for you what I'm going to be expecting you to do in just a few minutes on your own independently. Okay? So we're going to do the same thing with the 3s, but we're going to switch our colors. So now I have 3. I'm repeating addition here. 3 plus 3 is 6. Plus 3 is 9. Plus 3 is 12. Plus 3 is 15. Plus 3 is 18. Oh, so our pattern looks a little bit different for 3s than it does for the 2s. Okay? Starting to see how this is starting to go on a diagonal. Okay, so let's see if we actually make diagonal lines in our pattern. Okay, so 3, 6, 9, 12, 15, 18, 21. Plus 3 is 24. Plus 3 is 27. Plus 3 is 30. Plus 3 is 33. Plus 3 is 36. Plus 3 is 39. So I'm going to highlight those. I'm not going to be able to necessarily highlight it in the same fashion that I did with my orange color-coded 2s because our pattern looks a little bit different. However, we might be able to continue going down that way, but because it's not straight up and down in a vertical line, we're just going to keep counting by 3s. So we get to 42, then we get to 45, then 48, then 51. Okay. Again, coloring those in. Okay. Pausing to help you catch up. Then we have 54. Then we have 57. Then we have 60. Okay. Then we have 63. Then we have 66. Then we have 69. Okay. Again, continuing to count by 3s. Then we have 72. Then we have 75. Then we have 78. Then we have 81. 84. Plus 3 is 87. Plus 3 is 90. Plus 3 is 93. Plus 3 is 96. Plus 3 is 99. Okay, so yes, we created the 3s are in diagonal, they're in diagonals, going down to the left. In diagonals going down to the left. Okay? Anything else that you can tell me about that pattern? Do all of our numbers end in certain numbers? Well, let's see. We have one with a 3, one with a 2, one with a 1. We have 6, 5, 4, 3, 2, 1. So there is a pattern diagonally there. 6, 5, 4, 3, 2, 1. 98765431, 098765430, 0987609. So you could say there is a pattern that goes 09876 down the diagonal. Okay, down the diagonal there. Now, we're going to go on to the 4s, okay? But I'm going to tell you there is something really cool about 3s in terms of divisibility, okay? And I'm going to talk to you a little bit about how you can determine if any number is divisible by 3. But we'll come back to that. It's pretty cool. All right, we're going to move on to the 4s. So we're going to do the same thing, but we are switching our color, okay? This time I'm going to highlight with yellow. And again, the same process. We're counting by 4 repeated addition. 4, 8, plus 4 is 12, 16, 20, 24, 28. Now this pattern looks way different than the other two, right? What comes after 28? 32, 36, and 40. Okay, I'm going to pause there and I want us to turn and talk. What do you notice about this pattern? Okay, hopefully you were telling me that it's every other one going down the vertical column. So we can then be under the assumption 4, we skip 14, it's 24. So 44 would then be a multiple of 4. 64 would be a multiple of 4. 84 would be a multiple of 4 if it followed that every other down the vertical pattern. But we're going to continue highlighting and to make sure that that's the case before we actually write it down. Okay, so now we have 44, 52, adding 4, 56, adding 4, 60, 64, 68, 72, 76, 80, 84, 88, 92, 96, and 100. Okay, so that pattern did in fact work out. We are skipping every other one going down the vertical column. Okay, so with the 4s, they are in vertical columns, skipping every other 10. So 4 plus 10 is 14, plus 10 is 24, plus 10 is 34, plus 10 is 44, plus 10 is 54. It's skipping every other 10. 4 to 24, to 44, to 64, to 84. Are there any other patterns? What can you tell me about what the numbers are ending in? Hopefully you're looking to see they are ending in 2s, 4s, 6s, 8s, and 0s. So they end in 2, 4, 6, 8, and 0. Now, I'm just going to bring this down for a second just so we can look at the similarities and differences here, okay, between our 2s and 4s, because the 2s and 4s are quite similar, right? They both have vertical rows, but in the 4s, you're skipping what you didn't do in the 2s, okay? So the 2s and the 4s, again, are even numbers. The 3s have even and odd numbers. Odd, even, odd. Even, odd, even, odd, even, odd. So we're going to add that now to our pattern here. Okay, we have even, odd, pattern. This is all even. And then this is all even. Okay, now I'm going to pause there for a second because your task, okay, is going to be working with a partner that I have assigned you to, you are going to be continuing to figure out what the patterns are in the mini hundreds charts, following the same type of I notice scenarios, okay? Same type of thing. And it's okay to put the whole picture together, then go back and recognize and find even other patterns. And you might be able to work with your partner and find even more patterns in the numbers that we've already done. So your task with your partner is going to be to continue your hundreds charts, doing the 5s, the 6s, the 7s, the 8s, the 9s, and the 10s. Now, this is not something where you work with a partner and your partner does one chart and you do the other and then you copy off each other. No, you are working with your partner to identify all of the patterns for each of the numbers. So you're working in your own book, figuring out and discussing the 5s. Then you're moving on to figure out and discuss the 6s together with your partner. And you're discussing and talking using mathematical vocabulary such as vertical, horizontal, diagonal, even, odd, pattern, okay? You're using that as part of your discussion, okay? And when you are finished with the 5s, the 6s, the 7s, the 8s, the 9s, and the 10s, then you will come to me and let me know, and I will let you know what you are going to be doing next. Questions? Please let me know.